Hey guys, welcome back. So in this video we'll be going to discuss on the plate with a hole experiment. So this experiment is nothing but a rectangular plate with a circular part extruded from it. So the dimensions are given as per the diagram, and a displacement load is assigned on the left part of the rectangle and the pressure load is assigned on the right part of the rectangle. So the pressure is calculated and we got it as 20 Newton per mm square. So let's start the structural part in the ANSYS window. Hey guys, welcome back. So let's start the structural part for the plate with the hole. Starting with the preferences, we'll choose the structural, going on with the preprocessor, element type. We'll add the element type, which is solid pad 4 node 42. Make sure this is selected and click on OK and close it. So just before proceeding further, we'll add another parameter over here, which is we'll be going to options. Make sure the plane 42 is selected, and in options we'll be changing the element behavior K3. So the plane stress will be selected by default. We should change it to plane stress with thickness. So this should be the change we should do, and we can just save it, close, and now we can add the real constant, add, and here we'll be asked to enter the thickness value, which is given in the question as 10 mm. Okay, and close it. Now we'll just move on to add the material models and material properties. Material model number 1, and going to structural, linear, elastic, isotropic, and the given Young's modulus is 200 E3, with the Poisson's ratio can be taken as 2.87, 0.27. So click on OK and close the window. Now let's start with the modeling part. So we'll be creating two areas over here, which is a rectangle and a circle. So create areas, and first we'll be starting with the creation of rectangle by two corners. So here we'll be asked to enter the x, y, width and height. So the x should be 0 and y should be 0, and the width will be taken as 80 and 50 would be the height. So 80 and 50 are the given parameters. Here x and y will be taking as 0, 0, because to start our rectangle from the origin. So we'll just click on OK. So the rectangle has been created. Now we'll just create with the circle, solid circle, and here we'll be asked to enter the x, y and radius. So the circle should be mounted exactly on the center of the rectangle. So the x should be 40, which is half of the rectangle size, and y should be 25, which is half of the rectangle's height. And the radius should be 5 as per the given question. Clicking on OK. So we have got the circle, but we'll have to extrude the circle from the rectangle. Now we'll go to operate. In operate, select Boolean. In Boolean, we'll have to go to subtract, and in subtract, we'll be selecting areas. So first, we'll be just clicking on the outer surface of the rectangle, and now we'll just click on OK. Again, when we click on the outer surface of the rectangle, the circle area will be automatically selected, or sometimes the entire area will be selected and a pop-up window would appear over here. You can just select on the previous button, which will be appearing on the pop-up window, and you can get the circle automatically selected. So by clicking on OK, we'll get the circle extruded from the rectangle. Now we can proceed with next, which is meshing. So let's move on to meshing then. In meshing, we'll be going with the mesh tool. Here we'll be adding few changes in this, which is we'll be enabling the smart size, and also we'll be reducing the fine and coarse to 3. So the minimum should be 3, and we can just click on mesh over here. So this applies the mesh part. For this, when we click on mesh, we can just click on the outer surface of the rectangle and click on OK. So now the meshing part has been done. Now we can move on to apply loads on the plate. So let's go to loads, define loads, apply structural, and first. Now here we'll be adding two types of load. So the one type of load will be acting on the left side of the plate, and which is displacement load, and on the right side of the plate the pressure load will be acting. So let's start with the displacement load on nodes. Let's just click the right part of the, I'm sorry, let's go with the lines. So let's go with the displacement lines and just click on the left part of the plate, click on OK. So we'll be constraining all degrees of freedom and click on the displacement value as 0 and click on OK. So now we'll be assigning the pressure on the right side. So on clicking on pressure and on lines, we'll be selecting the right part of the plate, clicking on OK. So the pressure value, so the load value of load pressure should be minus 20. So the negative sign is because it should be acting on the inverse direction. So it's necessary to assign a negative value for 20 according to the given problem. So let's click on OK. Now we'll just move on with the next part, which is getting the solution. We'll just verify our problem by getting the solution is done. So we can verify to go with the next part. So which is general processor. In general processor, we'll be defining a table for stress. So going with the element table, define table, add, and we'll be adding the label as stress with the result data item selected as stress, and the one MySys SEQV will be selected. So these are the parameters should be selected for defining this table, and clicking on OK, just close it. So now we'll be going to plot results. In plot results, go to counter plot. You can go to the line element result. Sorry, go to nodal solution. In nodal solution, just gain the displacement vector sum and get this diagram. You can verify this, and also in the same plot results, we'll go to element table. In element table, make sure the item to be plotted as stress to be selected. As we have defined it on the element table, the stress will be selected by default. Clicking on OK, we'll get this exact thermal kind of interface. So we'll just go with the next part, which is adding points on this. Before adding points, we'll just zoom this part because we'll be adding some points from this section to the darker blue section. So in this general processor, we'll be going to the path operations. We'll just search for the path operation over here, and we'll get the path operation, and then go to define path. In define path, go to by nodes. So we'll be selecting each nodes from the darker region of red to the darker region of blue just by clicking on the outer layer of the circle. So just do the same exact step. Add as much as nodes as possible from darker of red to the darker region of blue. So after adding sufficient points between them, we can just click on OK. We'll have to define a path name which we can define it as a graph. Just click on OK. So we'll get a brief overview of many points and sets we have done. So we'll just get the status. We'll just close that. Now moving on to the next part, which is we'll just map this path. So we'll just go to map onto path and make sure stress is selected and one MySys SEQ should be selected. Just clicking on OK over here. And after this, no changes will be displayed, but after this, we'll be going to plot path item. Here we'll be selecting on graph. So without doing this map onto path step, we'll not get this SEQE. So make sure after creating map onto path, then we'll come to plot path item. So then we'll be getting this SEQE before, because we'll be defining this thing in map onto path, which just selecting this SEQE and clicking on OK. So by this step, we'll be getting a graph for our problem. So graph with node values will be getting. You can just copy or draw this graph. So yeah, this completes the problem actually. We can even animate this step by going to style in plot controls, size and shape, make sure the display of element is on, and so for this to be enabled, I think we should be closing this graph. So just go to plot result. In counter plot, we'll be just getting the displacement vector sum and click on OK. So right now we'll be getting the animation. You can just follow the same procedure. So the display of element is on, and now we can go to plot controls, animate, and deformed shape. So make sure deformed plus undeformed is selected. Clicking on OK, the animation for this respective problem will be played. So this completes the the plate with a whole problem. And if there are any mistakes in the values which you are getting in the results, make sure to input the exact given values from the question. So, but follow the same steps which is provided in this video, and you'll get the result. So, thank you for watching.